Hi everybody, welcome to the course What is RBI? This course has been prepared by our group RBI Clue, and this is one of the most comprehensive courses for those who are not really familiar with RBI and all the concepts related to that, or it's not their job, and it will teach you everything that you need. So what are the course objectives? So after successful completion of this course, you will learn all concepts of risk-based inspection. You can apply general RBI methodologies in your daily work routine. You will understand all the RBI language, including terms, definitions, and acronyms. You will understand about RBI scope, approaches, and planning process. And you will understand about factors affecting the probability and consequence of a failure. Also, you will learn about and you will understand the RBI qualitative and quantitative approaches. You will learn how to do RBI assessment based on deterioration mechanisms. You will learn the proper procedure for risk determination, assessment, and management. You will learn how to do risk management with inspection activities. And eventually you will learn the fundamentals of risk analysis from both probability and consequence sides of it. So this is a very comprehensive course about RBI and teaches you everything A to Z, and it will help you understand all the concepts related API to API 580 and all the basics of the RBI, and it will prepare you for any type of work related to RBI and to be successful in that career. So let's jump to the course. So let's start with the introduction section. What is RBI? So in this section, we're gonna talk about an example of an RBI assessment. We'll talk about RBI definition. We'll talk about RBI cost savings. And we're gonna talk about why RBI is getting more attention these days. And eventually, we'll say who is an RBI specialist. So before we start talking about those long sentences and descriptions about RBI and all the theories and everything, let's jump into an example and to show you what an RBI assessment is and how it's done on a piece of equipment in a very brief way. So, during the RBI assessment, one of the first steps that you would do is to do a kind of equipment overview. It basically means that you go into the details of all the histories about that equipment and then about all the process information and the temperature, pressure, and all those type of stuff, and where that equipment is located, and all those type of stuff. But let's jump into the very brief overview of a specific equipment. So imagine we have a drum XX that is a horizontal carbon steel drum which handles C3 and C4 released from another drum and various other thermal relief valves via flare header, and it relieves to the flare via another drum. This drum also handles degassing of sour water feed coming from another drum, the ZZ. So this is a kind of overview of that drum. It gives us an idea of what that drum does. And then we review the history of that drum. So we know that this drum was installed in 1972. In 1985, it was they replaced the 4 heater sleeves. The bottom portion of the drum was sandblasted prior to the installation of the cement liner. So we know that cement liner was installed in 1985. In 1999, the internal side of the vessel was stripped of gunite and sandblasted. It doesn't say more about what happened next. It just says that it was sandblasted. In 2009, the bottom third of the shell was sandblasted and coated with Belzona. So it was coated in 2009, and in 2016 the drum was sandblasted and recoated with Belzona again. So it sounds like there is a kind of history of losing that liner. So then we review the equipment components from the drawings and all those type of histories that we have. So we know that there are electric heater sleeves inside the drum. There are insulated nozzles outside. There are STCs and trim piping attached to this drum, which is common. Shell, obviously, the main components of the vessel. And then we do kind of review on all the deterioration mechanisms that are applicable to this drum. So we have to consider every single component and see what type of damage mechanisms are applicable to each component. So we make a table, and based on the information that we gathered so far, we know that the heater sleeves are basically can be deteriorated due to sour water corrosion, and the fouling is also applicable to the outer surface of that. The nozzles that are insulated and can be affected by corrosion under insulation, or CUI, which is an external mechanism. The STCs and trim piping of this vessel are under the stagnant zone corrosion internally. Then the shell is basically affected internally by wet H2S cracking and sour water corrosion, and externally by atmospheric corrosion because it's not insulated and it's exposed to atmospheric condition. And now let's talk about just one of the components. This is an example of the way that we do the RBI assessment on a specific corrosion mechanism. We have a course about RBI in CUI or RBI in corrosion under insulation. It's very important to learn these type of methodologies for doing RBI on a specific type of corrosion mechanisms, and because for every corrosion mechanism you have to do your own RBI assessment. But here I'm just giving you an example, for doing the RBI in CUI. If you want to learn more about this specific type of RBI, you can always go to our course. We have a basic course and we have an advanced course for RBI in CUI. And I strongly recommend you to go to those courses and learn those also. But let's jump into this one. So on the insulated nozzles, we know that the component is low frequency of condensation and low pollution. So the environment factor is +10. The component is exposed to steam leak due to steam leak to this nozzle based on the history review. So the W factor is +20. The component is older than 30 years based on the history, so the A factor is 50. The component has recently been coated with TSA based on the history, so the coating factor is -40. Component temperature is in the range of 80 to 100 Fahrenheit, so the T factor is 0. And no rust staining in the last external report, so L factor is 0. So the PF is basically the total of these numbers, which is 40, and it falls into the probability of D range. So the probability was considered as D. This is just an example of the way that RBI assessment on a specific corrosion mechanism is done, and you have to know all those kind of factors and the way those factors are applied and all those kind of stuff. So after we determine these numbers and we do the risk assessment on every corrosion mechanism, then we determine the risk for every single corrosion mechanism based on the current date and based on the future transitions. So as you see here, we have a list of components at the left, and then we have deterioration mechanisms applicable to them. We just talked about these. And then based on the corrosion mechanisms, we determine the base probability for each of those deteriorations. And then we calculated the shear risk, current, and fin risk current. So basically shear risk is safety, health, and environmental risks, and fin risk is the financial risk to the refinery based on our risk assessments. As you see, some of the, for example, the first two The shear risk is NA is not applicable, just because if that corrosion or that deterioration happens, it doesn't affect the financial risk, the safety and health risk, but it will cost us something. So it means that the financial risk is only applicable. The transition date was basically not applicable in this example, and the future shear risk and fin risk, so obviously it doesn't change with time. So now we determine the strategies or the risk mitigation tasks. Now we know the components, the deterioration, the risks, so we determine the tasks that need to be done to reduce the risk, to mitigate the risk, and the total cost of that task and the task due date. We determine the task due date that task needs to be done before that date. Otherwise, the risk might be escalated, or we will be non-compliance. And it's a kind of risk to the facility because it has liability for management. And then we determine the responsibility of each of these tasks, who needs to do what, and the task impact. So does it need the plant to go in a kind of shutdown scenario or a slowdown scenario, or it doesn't have any impact on the facility, or that task can be done on a stream and you don't need to do anything. Sometimes you have to put the equipment offline, but it doesn't affect anything at the plant, at the facility, in a short period of time. Sometimes if you put it offline, then it needs a shutdown or a kind of turnaround scenario for the whole plant. Or sometimes it just needs a kind of a slowdown scenario. It doesn't cost, it doesn't cause us to go through the shutdown process, but it still reduces the production, and obviously we lose money every day. So all those type of things need to be considered in an RBI assessment. RBI definition. Risk-based inspection, or RBI, is a process that determines risks by determining the probability of failure and the consequence of failure associated with each component of an equipment item and the tasks required to manage the risks. So as you saw in the last example, we determine the probability, and then obviously we determine the consequence, and by multiplying these two we determine the risk for CUI and also the other deterioration mechanisms, and then we made the table for every single component and all the related deterioration mechanisms for each component. And then based on that we determine the tasks that need to be done to reduce the risk to a lower level if needed. A properly implemented RBI program categorizes individual pieces of equipment by their risks and prioritizes inspection efforts based on this categorization. Typically, less than 10% of an organization's assets are driving 90% of the risk. Most people who work at facilities know that there are some specific bad actors at the facility that are mostly have problems or failures and stuff like that, and you have to take care of them all the time. RBI is used to identify and understand risks, risk drivers, and where equipment is in its life cycle. So it determines basically how much time we have to use this equipment and when we should replace it or repair it or take any other actions. RBI can indicate whether inspection is needed or not. So in so many cases, you don't need to inspect everything. You may need to inspect a specific equipment. So if you do that, then you won't waste your money on inspecting other stuff that are basically safe at this point, and you don't need to do any sort of inspection or other type of tasks for them. RBI should not be used to recommend any inspection when it will not improve knowledge about the damaged state. So if you don't need to do inspection, you should not waste your money. You should put that money into something else. In those cases where probability is driving the risk, RBI should point to other mitigation options such as replacement, repair, or other actions that satisfy the risk criteria. So if you are basically managing the risk by probability, and we'll talk about these things in the future, but if that's the way you're doing risk assessment and risk mitigation, then in some cases you don't need to reduce the risk by only inspection. Sometimes you can't do that. In some specific damage mechanisms, inspection doesn't save anything for you, doesn't help you like avoid any type of risk. So you have to do other type of activities in order to reduce the risk. And we'll talk about them in the future. Now let's talk about RBI cost savings and see how RBI helps us save money basically. So primary cost savings are moving from a time-based to risk-based approach, and in some cases inspection less, but also apply more effective inspection techniques to look for appropriate damage mechanisms. The key is to focus resources on the 5 to 10% of the assets that are driving the bulk of the risk. But in general, the cost benefits of RBI are, it generally requires 50 to 90% fewer inspection points than a traditional API inspection program, while reducing the risk of failure by 80 to 95%. Extends plant shutdown intervals and reduces the number of equipment items being opened by 30 to 60%. You won't need to open all the equipment. You just open those equipment during the turnaround that are required based on RBI program. Over a 5-year period, the benefit of RBI is generally 5 to 20 times the cost of its implementation and management. So although RBI costs you in case of like sending people for a training and have some RBI specialists on site and do some paperwork with management to just accept the risk of some of those equipment and move on without doing anything on those specific equipment, over time it will save you 5 to 20 times higher than the cost that you incurred at first stage. One of the biggest companies in oil and gas industry in North America, they saved $1 billion in 2019 just with the help of RBI program. Just keep that in mind, how much money you can save. Once the RBI program is operational, inspection learning is fed back to help lower the risk profile of an asset's equipment. RBI also identifies when to perform fitness for service assessments and to provide information to help make informed decisions about how, when, and where to inspect. So obviously when you have an RBI program, you don't need to inspect every single part of your piping system. You only focus on those areas of specific pipes that are more prone to specific damage mechanisms, because RBI in every corrosion mechanism is different and unique. So again, as an example, if you have an RBI in corrosion under installation program, I'm just giving you one example, one of the damage mechanisms among all hundreds of corrosion mechanisms. If you have an RBI in CUI program, then you won't need to do an inspection on every single equipment that is insulated. You only focus on those equipment that based on your RBI program are more concerning and more prone to any sort of damage due to corrosion under installation. So you save so much money by just doing RBI at your facility. So why these days RBI is getting more attention than before? It wasn't like that like 5 years ago or 6 years ago. Now it's getting more attention every year. And this is the reason. Oil and gas facilities are getting older. The older a facility is, meaning the closer to its end of life, the higher the risks, because the damage mechanisms has affected every piece of equipment in a facility. Every equipment is closer to the end of life, and it has lost thickness, so any type of leak or failure might happen at any point in time, and it's happening right now, and it has caused a lot of cost to the company, a lot of risks to personnel, to the public, and to the environment. Government and society are now stricter about the health and safety of public. Like 30 years ago, 50 years ago, even in North America, if there was an explosion, some people would die. And yeah, I mean, it was a kind of coverage in some of the local news, and it could be like the end of the story. Today, if there is an explosion, if just one person is injured, you hear about that everywhere, in all the media, especially social media. It has affected a lot. The environmental consequences are now way more concerning than the past. Like 30 years ago, nobody were talking about like environmental consequences or, the impact of the industry on our environment. Today, this is a big challenge for everybody. So everybody is more sensitive about these type of leaks or, damages to the environment. And if there is anything like that anywhere in any facility, it will be on social media, everybody will talk about that, and it has some influence on those companies. More competition in industry needs more financial risk calculation and accepting some risks to reduce the costs. So the oil price has changed a lot. There have been a lot of fluctuations in oil and gas prices. Obviously, it's down. It's not comparable to like 2008 or 2010, and the companies are competing with each other to gain more money and to have more revenue. So the competition is actually way more than before. So if you can save money these days, you obviously have more chance to win the competition because you have less cost. And with the same revenue, you can win the game. So obviously, less risks and less inspection, less cost, more competition. Media, and specifically social media, could easily affect the reputation of corporations. Just keep that in mind that all corporations, most of them, have stock on market, and if anything happens and it is covered by social media and everybody talks about that, in a couple of hours the stock of that company goes down significantly, and it can affect everything in that company financially especially. So this is important for those companies to have a good reputation and to avoid these type of things to happen. Any type of failure or anything like that. So it is important for them to have a good and reliable facility. So RBI helps them to have a better facility, to have a safer and more reliable facility, and to avoid these type of problems. Nowadays, we know more about the risks in the industry than before, so we are more concerned. Obviously, if you just look at the code book or the recommended practices like API 571 or even ASME codes, it has changed a lot since 50 years ago or 40 years ago. So 50 years ago, we weren't familiar with all the corrosion mechanisms that we are now today. So today we know that we are dealing with so many damage mechanisms, so many failures that might happen, and we are more concerned than like 100 years ago or 50 years ago. So these things forces us to consider RBI in our facilities and use these type of methodologies to have a safer and more reliable facility. Okay, now let's talk about RBI Specialist. And basically, we need to know who is an RBI Specialist, what that person needs to know. Basically, RBI Specialist must be familiar with RBI, obviously, risk-based inspection methodologies and assessments, which is the basic thing for RBI. Pressure equipment inspection. It is better for an RBI Specialist to be familiar with the concepts of inspection. If that person is an API 510 or 570 or 653 inspector, then obviously he or she might be more familiar with the concepts of inspection, and it will help that person more. But if you're not, I'm not saying that you're losing something. It is better to know those type of stuff. Next one is corrosion science. I strongly recommend you to be a corrosion specialist as well. And in order to do so, you don't need to do so many stuff. As long as you're familiar with API 571 recommended practice, you should be good. And I strongly recommend you, if you want to work as an RBI specialist in this industry, consider taking API 571 exam, because it gives you the certificate. First of all, it shows that you're familiar with all the corrosion mechanisms affecting refineries and pipelines and all those type of things applicable related to corrosion. And certainly if there is any type of incidents in the future, and if you have done any sort of assessment, RBI assessments including corrosion and the damage mechanisms assessments, then it shows that you are familiar enough with all those concepts, and it will be less liability on you. That's why I strongly recommend all the students to consider API 571 certification as well. Welding, inspection, and engineering. This is the other concepts that you might need to be familiar with. This is not a must, but it is really good to be familiar with welding inspection and welding engineering. If you have no background in these things, that's fine, but you can take some courses to be familiar with these concepts. We provide these type of courses as well. And the last one is reliability engineering. And you don't need, again, to be a kind of reliability engineer. As long as you're familiar with some basic concepts related to reliability, you should be fine. And if you're not, you can just Google it. You can find a lot of resources on internet to learn about reliability engineering, about bad actors, and all those type of stuff that reliability engineers do. Okay, guys, we just finished the introduction to this course. If you are interested in learning more about RBI and you want to take the What is RBI course, we have a free course with the same name and with the same picture as kind of thumbnail for the course on our website. It's just free course. Just keep that in mind. You just need to click on the link underneath this video in our YouTube channel and go there and take the rest of the course. You have just covered the introduction lesson. Lesson 1 and lesson 2 are basically in that course, and you can take the rest of the course on the website. And we also have more courses, more advanced courses about risk-based inspection. So if you are interested in those courses, you can always come back to our website and take those courses also. So I hope that you enjoyed this free introduction course, and I hope that I can see you guys in the basic course RBI, What is RBI course on our website, which is a free course. Thank you. See you soon.